we're going to build out an icon component. And I'm really excited about this video because I made a similar video about 3 years ago. But in this video, we're going to use a completely different approach, and I actually think it is way better. Previously, I turned each icon into its own JSX component, but recently Ben Adam wrote a blog post called The Best Way to Manage Icons in React.js, and I'll include a link in the description below, but the TLDR is that an SVG Sprite gives you the best performance. In fact, Kent C. Dodds recently incorporated Ben's code for generating SVG sprites into his Epic stack. And so we'll build something similar using the same script, but in our Redwood.js stack. And I did want to point out that even though we're working within the context of Redwood, this can be used within any React project. So let's get into it. If you're new to the Self Teach Me channel, my name is Amy Dutton. I'm a web designer and developer, and I want to help you level up and get you to where you want to be. So if this sounds interesting to you, hit the subscribe button below. Now, this video is part 10 in a multi-part series on building a full stack application within Redwood.js. And if you want to follow along, I've included a link to all of the code on GitHub in the description below. You can clone it to your computer, navigate to the section that you're looking for, run yarn install to download all the dependencies, and then yarn redwood dev to run the project. If you want to jump around within this video, I've included chapter marks in the description below to make it easy to find what you're looking for. Let's start by doing this the old-fashioned way. That way you can understand what our script needs to do, and then we'll come back and automate it with code. Let's start by exporting all of the icon assets that we need out of Figma. So first we need to select an icon by command clicking on the icon itself. But in some cases, like this arrow, for example, it only selected a piece of the icon. So you'll want to make sure that you're looking at the layers panel and that you're grabbing the frame for the icon. So each icon should be 24 pixels by 24 pixels. And that's a key part in creating an icon component. All the icons are the same size, and this will make it a whole lot easier to handle each icon consistently. So once the frame is selected within Figma, you can come over to the export panel here on the right side. And if your panel looks slightly different than mine, probably looks like this, you can click on the plus icon, and then you'll want to select SVG from the dropdown. Then you can click on the export button and save that to your desktop or wherever you want to save it. So if you don't want to mess with Figma at all, but you still want to follow along, I've included an export of all of the icons as SVGs and stuck them on Google Drive for you to download. I'll include a link in the description below. Once you have all the icons exported, and I'm going to cheat a little bit, I've selected the entire frame. I'm going to hit Command-Shift-G to ungroup all of these, and now I can just come straight down and export all of these at once. And it'll say that, hey, you already exported the arrow.svg icon. Do you want to replace what's currently there? Yes, I do. Let's start by doing this the old-fashioned way. That way you can understand what our script needs to do, and then we'll come back and automate it with code. So now we can come over to VS Code, and I'm going to drop all of the icons into our project. So inside of our scripts folder here, I'm going to create a new folder called SVG-icons. Then I'm going to drop all of our SVGs into that SVG icons folder. Next up, let's create a file for our SVG Sprite. And remember, anything inside of our web public directory that gets exported and is available within the browser after our project has compiled. So inside of our public directory, I'm going to create a new folder here called icons. And inside, I'm going to create a new file called sprite.svg. The top of our file, let's write an SVG tag. And we'll want to make sure that that's closing. And then I'm going to add an attribute that says XMLNS. And what this does is it tells the browser which SVG spec that we're going to use. So I'm going to set this to http://www.w3.org/2000/SVG. Then we want to create a defs tag inside. And this is short for definitions. So all of our SVG icons are going to live inside this tag. Next up, we'll want to add a symbol. So each icon will have its own symbol. So if we have 20 icons, we'll have 20 symbols. And each symbol is going to have an ID attribute on it. And what this does is it will allow us to reference a specific icon within our React icon component. So for this first one, let's set this to be arrow. Then we need to set up our ViewBox. And really the ViewBox describes a window into our SVG. If you think of it like graph paper, the first number is the X value and the second number is the Y value for the starting coordinate. The third number is the X value for the ending coordinate, and the fourth number is the Y value for the ending coordinate. Usually the first two numbers are 0, 0 since you're starting at the origin, and the third number usually matches the width, and the fourth number usually matches the height. Now that you understand what the numbers represent, you can see we've created a little box that serves as a viewing window. Now, the nice thing about the view box is once it's set, it allows your SVG to maintain its aspect ratio. So for our purposes, we'll set the view box to be 0, 0, 24, 24. And then inside, let's add a title tag. And we'll want to make sure that this closes as well. What the title does is it allows our sprite to be more accessible. This is the arrow icon, so I want the title here to match. Then we'll want to include a path. And I'm going to pull up our arrow.svg. And here you'll see that we have a path tag. I'm just going to copy this. I'm going to paste this directly into our sprite.svg. Now, we still need to do a little bit of cleanup. On our path, there are a few attributes that we don't need. So first, we can get rid of this fill attribute that's on the end. And the reason why is this fill attribute works like an inline style. So if we try to control the color through CSS, it won't take any effect because that fill attribute will override it. So we want to get rid of it. Then we'll want to remove our fill-rule here at the beginning and our clip-rule. Now, usually these don't have any effect on your icon, but if you do have a complex icon, then you may find that removing these two attributes causes problems. So you'll just need to double check. Okay, cool. So now that our arrow is set up, let's move over to React and set up an icon component that will reference this SVG sprite that we just created. So in the terminal, I'm going to use our Redwood generators to create an icon component. So I'm going to say yarn redwood generate component icon. And this will create a few files for us inside of our components directory. So if we look inside of our web source components directory, we now have an icon folder with a Storybook file, a test file, and a component file. So let's pull up our component file. And I'm going to get rid of the boilerplate code inside. Instead of returning a div, I want to return an SVG. And this is going to be another SVG that's going to reference the icon sprite that we just built. So let's set the width and the height for our SVG. And we want to do this dynamically. But since we know that we are working with a square, we can just pass in a single size prop to our component and set both the width and the height to size. So by default, I'm going to set this to be 24 pixels since all of the icons that we're exporting out of Figma are 24 pixels by 24 pixels. Now inside of our SVG, let's add a use tag. And what this is going to do is it's going to allow us to specify which symbol within our sprite.svg we want to use. So I'm going to make this self-closing and I'm going to pass this an href attribute. I'm going to point it to our icons/sprite.svg, except we want to use the symbol that we set up. So I'm going to add a hashtag to the end and say arrow. So now let's pull this up within Storybook and look at our icons. So in the terminal, I'm going to run yarn redwood storybook. So once this is up and running, it should pull up on port 7910. So I'm going to close our actions panel and I'm going to open our sidebar and come down to icon and check that out. There is our arrow icon. Awesome. The only thing is that every time we reference our icon component, it's going to show our arrow component and we want that to be dynamic. So I'm going to come back over to VS Code and I'm going to change this to use backticks instead of double quotes. So this will allow us to use string interpolation. If I wrap this with curly brackets so it knows, hey, we're using JavaScript. And then I can pass it a JavaScript variable. So I'm going to replace arrow here with $ curly brackets and add an ID prop. And of course, we'll need to make sure that we are passing that ID prop into our icon component. So now if I hit save, and if we come back over to Storybook, you should see nothing. And that's because we haven't specified an ID prop. I'm going to come back over to VS Code and let's pull up our icon.stories.tsx file. I'm going to come down to our primary story here, and I'm going to pass in an args object, and let's pass in an ID of arrow. And while we're here, let's also set the size to be 128. So now if we come back over to VS Code, there's our arrow and it's large and in charge. Pretty cool. Now there may be some other props that we want to pass into our icon component. So I'm going to use a spread operator. So if we come back over to our icon.tsx, and I'm going to say comma, ... props. So that means any other props that we pass into our icon, it all gets grouped into this props variable. And sometimes you'll see this listed as rest, like all the rest of the props get grouped into this. So really you could name this whatever you want. But what we can do now is on our SVG tag, we can say ... props inside of curly brackets. Now anything we add gets passed on to our SVG tag. Now, if you want to see this in action, let's go over to our icon.stories.tsx file, and I'm going to pass in a prop of class name, and I'm going to add a class of fill red 500. So if I save this and come back over to the browser and give this a refresh, you'll notice that my arrow is red. Pretty cool. Now, one thing that I like to do anytime I'm working with SVGs is within my CSS file. So that's under index.css. Inside of our base layer, I like to set up a generic SVG style. So I'm going to apply a fill-current. And you can see here the vanilla CSS that sets up is fill current color, is it sets the fill to whatever the current text color is. This makes it really easy to style since the SVG adopts or inherits whatever the text color is set to. So just to show you what that looks like, I'm going to come over to my icons.stories.tsx file. And instead of using a args object, I'm just going to comment this out for right now. I'm going to provide a render property. So this is going to render out a function. So I'm using parentheses here because I'm going to return our icon component. And I'm going to pass in an ID of arrow. Let's go ahead and leave the size at 128. And then let's wrap all of this with a div and set the text color here to be purple 500. So now if I save this and come back over to Storybook, we still have our arrow, except now it's colored purple because our text is colored purple. Cool. So this is great, but we still have several other icons that we need to set up. And we could do all this manually, copying and pasting paths from one file to the next. But let's do all this within code. That way we have a robust icon system. And we're not doing a bunch of busy work, copying and pasting, but also this script can get passed from one file to the next. So I'm going to come back over to VS Code and I'm going to scroll up to our scripts folder. And inside, I'm going to create a new file here called build-icons.mts. Notice that the extension is .mts, and that's because we're using ES modules. When you're working within Node, it will automatically treat your JavaScript code, or in this case, our TypeScript code, as common JS modules, meaning you have to use a require syntax for imports and module.exports for, well, module exports. But with ES modules, which uses ECMAScript, you can use the import syntax that we all love, or at least I do. And one way that you can enable ES modules is by specifying a type of module within your package.json file. And this works great if you're working within a purely Node project, but we have a React project. So instead, we can specify this file as using ECMAScript by using .mts. Conversely, never say the word conversely in real life. I could use .cts for common JS. Now, within our file, the first thing that I'm going to do is set up a few variables to make it easier to get around our project. So I'm going to get the current working directory. So I'm just going to use cwd as a shortcut, and I can set that to process.cwd. And if you're wondering where that comes from, that is actually part of Node.js. We have access to a method called process.cwd, and I'll include a link to this documentation within the description below. Then we want to grab all of the icons within our current working folder. So at the top of our file, I'm going to say import all as path from node path. Now, path also comes straight from Node. So I'll include a link to this documentation as well within the description. But this gives you some utilities for working with files and directory paths. So now within our code, we can say path.join CWD scripts SVG-icons. So here we're passing it strings for all of our paths, and it's going to join them together and return a new string. So we started in our root directory. That's our current working directory. And then we said the scripts folder and then our SVG folder. And again, that gets joined into a new string. So if you're using a different folder structure for your project, you'd want to modify this to make sure that you get to the right place. So I'm going to save this new path into a variable called input directory, since this is the input where we're going to input all of our SVGs. Now we want to get the relative path from our current working directory to our input directory. So Node has a method called relative where we can pass in two separate paths and it will return a relative path. So I'm going to say const input directory relative, and we're going to say path.relative. We're going to pass it the current working directory and our input directory, and it will determine the relative path between these two folders. Now let's set our output directory. So I'm going to say const output directory, and this is where we will output our final sprite.svg. So again, we can use our path.join method again. So I'm going to say path.join CWD for our current working directory. Then I want to go into our web folder, our public folder, and our icons folder. So remember, we set up this folder earlier when we were creating our sprite by hand. So we have our current working directory, which is our root. We go into our web directory, our public folder, and then our icons folder. Next up, we're going to use an MP package called fs-extra. And again, I'll include a link to this within the description below. So let's add it to our project. So I'm going to open up a new terminal pane and I'm going to say yarn add fs-extra. Now, remember, we've talked about before how Redwood uses workspaces. So we have a web workspace and an API workspace, depending on which part of our project that we're going to be working within. But since we're working in our scripts directory, that's not part of the front end or the back end. It's a script that we're running. We can simply say yarn add fs-extra without specifying a workspace. Once that's installed, we're going to use that package to ensure that this particular directory that we listed actually exists. So I'm going to say await fs-extra.ensure directory, and I'm going to check to make sure our output directory exists. Now, in order to use this, of course, we'll need to import this at the top of our file. So this is coming from fs-extra. Now we want to get a list of all of the SVGs inside of our folder and sort them alphabetically. So I'm going to say const files, and we can do this using glob. And this is another npm package that we'll need to import. And I'll include a link to this package within the description below. So again, in the terminal, I'm going to say yarn add glob and hit return. That'll import glob to our project. So here I can say const files equals glob, and we'll need to import this at the top of our file. So I'm going to say import glob from glob. Now, the nice thing about glob is it allows us to find files in our directories using patterns, kind of like wildcards. And there's a great article on LogRocket, and I'll also include this. So lots of links in the description. But this explains how glob matching works and how you can use wildcards or glob patterns to match file names. So I'm going to close this. So I'm going to come back over and I'm going to use sync to handle this synchronously. And the first parameter here is the pattern. So we'll go through all of the folders and we want to grab any file name with an extension of SVG. So I can just say star.svg. Now the second parameter is an options object. So we want to establish what the current working directory is. So that's our input directory that we set up here. And now we want to take this and we want to sort what we get. Now sort is an array method that is built into JavaScript. So I'll include a link to this within the description below. So the way that sort works is it takes two items. So I'm going to just say A and B, and it compares them. So I want to compare them based on the local language standard. So I can say A.local compare and pass in B. Now all of the elements are going to be sorted based on a way that makes sense for the user's locale. So I'm going to save this and it should reformat my code a little bit. Next up, we want to determine if we should include a lot of information or a little information within the terminal. So for example, if the user has a flag like log equals verbose when they run our script, then we'll want to display a lot of information. Otherwise, we can just keep it nice and simple. So first, we need to check the command prompt to see what the user said. And we can reference that by saying process arg v and checking to see if that includes -- log equals verbose. Now let's save this inside of a variable called should verbose log. So if log equals verbose exists, we'll get a true value. So should verbose log equals true. Otherwise, this will be set to false. Then let's set up a function called const log verbose. And we can say that if should verbose log is true, then we want to console.log. Otherwise, we just want to return an empty function. Okay, so just to make sure that we're clear, if should verbose log is true, then it's going to set log verbose to console.log, which means anytime we call log verbose, it's the same thing as saying console.log. But if we don't want it to be verbose, so should verbose log is false, that means it's going to return an empty function, which means that it's going to do nothing. So the nice way about setting this up in this particular format is that when we call this function log verbose, it can handle both use cases because we've mapped the function appropriately. Cool. Now we are getting a linting error here because this does need to be in quotes. We're checking for a string. Now let's check to make sure that there are SVGs within our folder. So I'm going to say if files.length equals 0, then we want to display a message in the console. So I'm going to say console.log, and we'll say no SVGs are found in our input directory. So I'm using console.log instead of log verbose because I want this message to be displayed in the terminal regardless if there was an error. And here we're just referencing the variable that we set up above with our input directory relative. So if there are files, then we want to set an else statement here. We want to generate our icon files and we want to await for this to happen. Now this function, generate icon files, does not exist yet. So we need to write that. So I'm going to hit Command C to copy the name there. And then let's come on down and let's say function. We're going to call generate icon files. Since we said that we want to wait for this to happen, we need to make sure that this is also set up as an async function. Now, first within our function, let's create a const sprite file path. And we can use our path.join trick again to set the output directory. So I'm going to say output directory, and then the file that I'm going to save to is going to be sprite.svg. Now, since we're using TypeScript, let's also create a file that contains all of our types. So I'm going to say const type output file path, and this will be the same as our sprite file path, except we're going to call our file here name.d.ts. Next up, we want to take our current sprite and we want to read the contents as UTF-8 encoded strings. So we can use our fs extra package again, and we want to read a file. So we're going to pass in our sprite file path name that we set here on line 30. And we want to make sure that it's set to reference UTF-8. And the reason that we're using UTF-8 is it takes any binary files and converts those into a string that we can actually read and compare and do things with. Now let's just make sure that it didn't catch any errors. And if it did, then we'll just return an empty string. And this will allow us to keep moving. We also want to await for this to happen. Now we want to do the same thing for our TypeScript file. So I'm going to hit Command-Shift-D to duplicate this line. And I'm going to change this to say current types. And I want it to use our type output file path to read it, convert that to a UTF-8. And if there are any problems, then again, it's just going to return an empty string. And just to be clear, the reason that we're returning an empty string if there are problems is that it allows the program to continue to run regardless of whether there were any issues or not. I'm going to save this and you'll probably see our file reformat a little bit. Now let's create an array of all of our icons, and we can use the file name, but I do need to remove the .svg from the end. So I'm going to loop over all of our file names and I'm going to run them through a function called icon name. And I'm going to pass in our file name to our function called icon name. And let's save this inside a variable called icon names. Now we just need to write this function that we said would return the file path without .svg on the end. So I'm going to say function icon name. And we already said that we're going to pass in the file name. So let's stick that in the parameter. And for TypeScript purposes, this is a string. And then we want to return the file without that .svg on the end. So I'm just going to use regex to say anything can be on the front here. But as soon as you find that pattern .svg, we're going to replace it with nothing. So that's an empty quotes there on the end. So, and then that gets returned to our icon names. And since we're mapping over everything, it's going to create a new array that gets saved inside of our icon names. And actually, this needs to run inside of our generate icon files function. Next up, we need to make sure that every icon has an ID. And we can do this with a JavaScript every method. And this comes straight from the API, and it'll test to see whether all elements in the array pass a test. So we can loop through on our icon names every element in that array. And for each iteration, we're going to call that name. And then we're going to check the current sprite that we've set up here on line 33. It includes ID equals the name that we got from our SVGs. So then we'll want to save this inside a variable called sprite up to date. And then we'll want to do the same thing for our types. So I'm going to change this to be types up to date. We're still going to loop over our icon names that we grabbed from our SVG folder. And we're going to check to make sure that our current TypeScript folder includes the name. And here we just need name straight up. Now let's write a conditional to make sure that our sprite up to date and our types up to date are true. So I'm going to say if our sprite up to date and our types up to date, then we want to use log verbose, and we can say that our icons are up to date, and then we're just going to return. Now remember, if we set the verbose flag within our command line, then our statement will display in the terminal. Otherwise, nothing is going to get displayed. So the nice thing about this code is it's going through and it's grabbing all of our SVG icons, and it's going to strip off this .svg. So it's going to look for Arrow, Facebook, GitHub, Hide, LinkedIn, YouTube, and see if those exist within our sprite.svg file. There's already a file there that exists, and within our TypeScript file, if that file already exists. And if everything already exists, then it's just going to display a message here that says icons are up to date. Otherwise, it's going to go through and it's going to generate a new SVG file. So it's not going to run that code unless we actually need it. So that return statement will have us exit out of this function. So if we do need to generate a new file, then this conditional won't be true and it'll get past our return statement. So let's go ahead and log out a verbose message just to say that we are generating our sprite for our input directory relative. So this will just help the user know where we are in the process. Let's create a variable called sprite changed, and let's have it run a function called generate SVG Sprite. And let's pass in our files, our input directory, and our output directory. Now we just need to write this function. So I'm going to come down to the end of our file here and say function, paste that in. And now we have our empty function that's going to run. So like we said, we're going to pass in our files, our input directory, and our output directory. And for TypeScript purposes, we can provide a little bit of information here. So we know that our files here is an array of strings. We know that our input directory is a string, and we also know that our output directory is a string. Let's generate a symbol for each icon, and we can just say await promise.all. And promise.all is a JavaScript method. Again, I'll include a link in the description below, but this allows us to use several promises, and then we'll return a single promise that's fulfilled when all of the promises are finished. Then we're going to map over each of the files that we passed in. So since we're using promises, we're going to say async. We're going to reference each iteration as file, and then we're going to run some functionality over each individual file. So let's create a variable here called input. And again, since we're using promises, I'm going to wait for this to run. We're going to use fs extra again to read our file. And the parameter that we're passing in is the path name. And we can use that path.join trick again. So I'm going to start with our input directory. And then I'm going to use our individual file that we're looping over here. And then I'm going to make sure that this is all UTF-8. So again, that just ensures that the file's binary data gets read as a UTF-8 string. And just for clarity, we're reading each of the files within our SVG icons folder using that fs extra read file. And we're passing in the file path. So that's our input directory plus that file name. And then we're using UTF-8 to make sure that that's a string that we can read. Okay, then we want to use another library called Node HTML Parser. And I'll include a link to this within the description below. But this will allow us to take something like an SVG, which is really XML, and convert it into a structure where we can easily manipulate it. So down here in the terminal, let's go ahead and add that package. So I'm going to say yarn add Node HTML Parser. And then now within our code, we can say const root equals parse input. So we're taking that file that we were able to grab here that we read using fs extra, and then we're going to parse it using that Node HTML parser package. Okay, then we need to make sure that parse gets imported correctly at the top of our file. So I'm going to say import parse from Node HTML parser. Now I'm going to jump down to the end of our code. So now we can create an SVG, and we can do that using this root that we just created with Node HTML parser. So I'm going to say root.querySelector, and we want to select an SVG. So if that doesn't exist, then let's throw a new error to say that there's no SVG element found. Now let's create a tag name. So I'm going to say svg.tagname, and we want that tag to be a symbol. I'm going to set the attribute of that. So svg.setAttribute to be ID, and we can use our file name. But again, we want to strip off that .svg, so we can call our icon name function that we created that will strip off that .svg extension. Now let's clean up our file. So remember, this is very similar to that process that we went through manually. So we want to remove attributes. We want to remove the XML in S :xlink. And we also want to remove version. If there's a version attribute, we want to remove the width and the height. And let's also remove any fill attributes. So we've removed these attributes from our SVG tag. We also need to remove some more attributes from our path tags. So an SVG can have several path tags included to create the shape. So we'll need to map over all of those. So I'm going to come down and I'm going to say const paths, and we can say query selector all. We're going to grab our path, and we're going to use a for to loop over all of those. So I'm going to say const path of paths, and then we want to say path.remove, and we're going to remove that fill attribute from every path. Cool. Now let's take our SVG and return it, except let's also make sure that it's a string, and we want to trim out any extra white space that we don't need. Now that we have all of our symbols, let's generate a string called output. And this is going to be an array here. And I'm going to put each line of our SVG within its own slot of the array. And then at the end, I can use a dot join to string everything together, separating a new line with the \n character. So for the content here, we'll say that we have an XML. We're using version 1.0 with the UTF-8 encoding. And then let's also include a comment here to say that this file is generated by yarn build icons. And we'll set that up later. Then I'm going to say our generic SVG tag, and I'm going to set the XML_ns attribute. Remember, we did all of this by hand before. So I'm going to set this to http://www.w3.org/2000/SVG. And then we'll also want to set up the XML_ns xlink. And I'm going to set this up to http://www.w3.org/1999/xlink. And let's also set the width here to be 0 and the height to be 0. So the user shouldn't be able to see the sprite on the page. And then we need to set up our defs tag. Then let's spread in our symbol. And then let's close our defs tag and close our SVG tag. Then let's add a trailing new line. I'm just going to put a comment here so that we know why that's an empty slot. Now let's return our SVG, but we only want to return the file if the SVG itself changed. So let's return this through a function called writeIfChanged, and we'll pass in our output directory and our output that we just wrote. Now we just need to write this function writeIfChanged. So I'm going to come on down, say function writeIfChanged, and this will be an async await function. We already know that we want to pass in our file path, which is a string, and we're also passing in our new content, which is also a string. Then I'm going to set the current content to use FS extra. And we did this before when we were reading our individual SVGs, but this time we want to read our existing SVG sprite if it exists. So we'll use the read file method. So we'll pass in our file path and say that we want that to be UTF-8. And if there aren't any errors, we'll just return an empty string again. Let's compare our current content to the new content. And if they're the same, then let's return false. If it's different, we'll await for the file to write. And we can say fsextra.write file. We'll pass in our file path along with the new content. And we want to make sure that that's using UTF-8. And we'll return true. Now let's go back to our generate icon files function. So if we come up here, here we go. We're inside of our generate icon files. And this is where we triggered our SVG sprite, which we did, but we need to add a few more things to this function. So first, let's loop over each file. So I can say file of files. And if we're being verbose, so we can call log verbose, display a message to the terminal. So I'm going to use a green check to say that we have our file, and I'm just going to pass over that file name, verbose. And then let's log another message. So I'm going to say log verbose, and I'm going to say saved to, and I'm going to list out our relative path. So I'm going to tell it to compare our current working directory with our sprite file path. So if all of this ran successfully, then it's going to list out all of the icons, and then it's going to say that it saved the new file and list out that file path. Next, let's generate our types file. So I'm going to loop over all of our icon names and stringify them. So I'm going to say const stringified icon names. And as I mentioned, I want to loop over all of those, and I'm going to refer to each iteration as name. And then I want to say json.stringify name. Then let's generate a giant string that will contain all of the contents of our TypeScript file. So I'm going to say const type output content, and we'll say this file is generated by yarn build icons. Again, we still need to write that script, but we'll do that. And then I'm going to say export type icon name. And then I'm going to use \T so that it will tab over. And I want to say stringified icon names dot join. And then it's going to have a new line and a new tab. Perfect. And then let's come on down here. And we want to say const types changed. And we're going to wait for this to run. We're going to say we only want it to run if the file changed. Now remember, we've already written this function. We just need to pass it the output file path along with our new content. So if it hasn't changed, it's not going to do anything. If it has changed, then it will write out a new file. And now I'm going to say log verbose, and we can say manifest saved to, and we can pass in that directory. So we can say path.relative. We want to use the current working directory compared to the type output file path that we set up. So it's just going to print out that relative path. Now let's do something really similar again, except this time we're going to generate a Readme. So I'm going to come on down and I'm going to say const Readme changed. And we're going to wait for this to run. And we're going to say that we only want to write this if something changed. And for this, we want to use our path.join trick to pass in the output directory plus the readme.md. So that's the path for our readme file. And then let's pass in our contents here. So I'm going to say that we have our icons, and we want to say that this directory contains SVG icons that are used by the app. And everything in this directory is generated by yarn build icons. That way, if the user opens the folder, that they'll see that, hey, all of the contents here is generated dynamically. Lastly, let's write a conditional to say that if our sprite changed, or if the types changed, or if our readme changed, we want to console.log out a message that say that we generated however many icons. And we can display that number dynamically by checking the length of our files array. Now I'm going to save all of this, and we need to install one more package in order to be able to run this script. So within the terminal below, I'm going to say yarn add TypeScript TSX, which will allow us to execute this TypeScript script that we've written. Cool. So I know this was a ton, but it's going to feel pretty magical anytime you run this script. So let's test it out, and let's hope that we don't have any typos. So I'm going to jump over to our package.json file that we have within the root of our directory, and we do not have a scripts section written yet. So I'm going to say comma scripts, and here we can establish any scripts that we want to be able to run. So we've already listed this out a couple of times dynamically, and we've said that we want this to be build icons. That's what we listed within our readme and at the top of our TypeScript file and at the top of our sprite.svg file. So here we want it to run TSX, and we're going to go into our scripts folder, and we want to run our build-icons.mts file. So I'm going to give this a save. And now within the terminal, we should be able to run yarn build icons. So I'm going to hit return, and it found an error. Awesome. Not awesome. Okay. So it says that there's an illegal operation on a directory. So let's do this to troubleshoot. If I come all the way down to my write if changed function, and let's just console.log out what it's getting here, the file path, and see what that returns. So if I hit save and then hit the up arrow to run this again, let's see, you can tell it has a file path here. And look, this is a folder. Interesting. Okay, so I'm going to delete our console.log. And if we come all the way back up to the top on line 31, you can see here is where we set our sprite file path. That's the file name that we want to be created. So this is the variable that we want to use. So I'm going to come on down, and here on 57, you can see that if the sprite changed, we're going to call our generate SVG Sprite function. And here we're passing in an object. And look, we're passing in the output directory which should be set to the Sprite file path instead of the output directory. So if I save this, now I'm going to hit the up arrow within the terminal to run this again. Check that out, generated 6 icons. Now, if we try this again, so I'm going to say dash dash log equals verbose and hit enter. You can see, look at that. It logged out the verbose messaging that we set up. Pretty cool, right? Now let's go back over to Storybook and make sure that our arrow story is still working. So if I pull up our icon component, check that out. Our arrow icon is still there, but we should go back and create stories for each of our icons. So I'm going to come back over to VS Code. So here in our icon.stories, we have our primary story. I'm going to update our story just a little bit so we can get rid of class name here. I'm also going to get rid of the size. So if I save this and come back over the browser, you can see there's our arrow story. Cool, that looks great. So I'm going to come back over to our story file. I'm going to change the name of this to arrow, and then I'm going to duplicate this for each icon that we set up. So we also have one set up for Facebook. We also have one set up for GitHub. We also have one set up for Hide. And we also have one set up for LinkedIn. And actually, this needs to be lowercase I. And then we also have one set up for YouTube. And I believe this is all lowercase as well. So now if we come back over to the browser, it's saying that it can't find our primary story because remember, we changed the name of our primary story to just be arrow. So now if we come through, check that out. There are all the icons that we generated. Looks like it had an issue with YouTube. Needs the T. Hit refresh. Awesome. That looks great. Now, one other thing, let's make sure that our type file has been created correctly. Okay, this looks great, except we have an extra curly bracket on the end. So let's go to our build-icons. And if we come on down to around line 70-ish, here we go on 73. Here's where we are setting up the content for our TypeScript file. And we have an extra curly bracket there. So if I save that, let's run our script again. And now if we check out our name.d.ts file, that has been fixed. Pretty cool. And then here's our Readme, which was also generated correctly. Sweet. Now let's take this one step further. Let's go back over to our original icon.tsx file. And let's make a few modifications for TypeScript since we generated a specific type definition file. So at the top of our file here, I'm going to say import type icon name from our public/icon/name.d.ts file. And this works just like a normal input, except here we're specifying that icon name are all types. Now we can create an interface to specify what each of our props are. So I'm going to call our interface icon props, and then we need to connect that to our component. So I can just say :icon props. Now we need to say all of the props that we're passing in. So we're passing in an ID, which is a type of icon name that we've imported. And then we're also passing in size, which is optional. So we're going to use a question mark and say that this is a number. I'm also going to specify that icon props extends react.svg props SVG element. And what this does is it lets TypeScript know that we are returning an SVG element and not just a regular div. So this will give it additional IntelliSense. Now, the benefit of doing this is now anytime someone wants to add an import and use our icon component, it will prompt them to use an ID that lines up with our SVG sprite and not just any old random string. So for example, if I come over to our nav, I'm just going to write some dummy code in here. But if I say we want to bring in our icon component, I'm going to hit return, which should automatically add our import at the top of the page. Now you can see that it's missing a property of ID. So I'm going to hit command period to say add missing attributes. And you can see that it already added an arrow here. But if I swap that out, all of a sudden I have IntelliSense for all of the IDs that we added, which is super helpful. Okay, so I'm going to remove this since we don't want this there in our final nav file. Now we're almost done, but a feature should never be called complete until we've written tests for it. So let's open up our icon.test.tsx file. Now, the first test that we have here is the test that Redwood automatically generated for us. And you'll see that it's telling us it's missing a property. So let's go ahead and add an ID here for arrow. Now let's run our test just to make sure that it's passing. So down in the terminal, I'm going to say yarn redwood test icon. Perfect. And you can see that our test is passing. Now let's test this to make sure that we can set a size. So I'm going to say it can be a specific size, and I'm going to pass it an empty function. Then we need to render out our components. So I'm just going to copy what we already have on line 11 and paste that into line 16. But since we're testing the size of our icon component, I'm going to also pass in a size prop of 64. We need to be able to grab our SVG so that we can set our expectations. So I'm going to go over to our icon.tsx file, and right on our SVG tag here, I'm going to add a data-test ID attribute, and I'm going to set this to icon. Now we can come back to our icon.test.tsx file, and I can say that I expect screen.getBy.test ID. I'm going to set that to icon, and I want to look for the width attribute, and I want to make sure that that is set to 64. Now, the reason it can't find this is because we also need to make sure that we are importing screen here at the top of our file. So now if you hit save, you'll notice that our tests are passing. Awesome. Now let's set up tests for all of our icons. And this would be another great opportunity to use snapshot tests. I first introduced snapshot tests in the last video. I'll include a link in the description below and the card up top. Now let's start with our arrow icon. So I'm going to come down and I'm going to say it displays an arrow icon, and we'll pass in a function. And inside we can say that we expect, and we want to render out our icon. So I'm just going to paste that in. And then I want this to match our snapshot. So now if I save this, this should run successfully and generate, check that out, a folder that includes all of our snapshots. Now I need to duplicate this, copy, paste for all of our different icons. So we have our Facebook icon. We have our GitHub icon. We have our hide icon. We have our LinkedIn icon. And we have a YouTube icon. So if I give this a save, check that out. All of our tests are passing successfully. Cool. Now, if an icon changes, it's going to break the test, but that's what we want. If this video is enough to get you to fall in love with SVGs, I have an entire YouTube series for working with SVGs. It's a few years old, but the content is evergreen. It's still true. It still applies. It still works. So I'll include a link to the playlist in the description below and the card above. So in the next video, we'll continue building out our Hacker News clone application, creating the shared link component. And this really is the heart and soul of the application, because without a shared link, the application would cease to exist. So you know it's going to be good content. If you like this video and want to see more videos on web design and development and don't want to miss future videos in this series, be sure to hit the subscribe button below, hit the bell icon to receive notifications when new videos are posted. Until then, keep coding.